One of you, can you confirm that? Am I clearly audible? Am I visible? Is everything good? Okay, nice. Okay, so we'll start. So first let's have some few discussions about the assignments. So how many of you have at least opened the assignments? Have you opened them? So how did you find them? Were they at least like understandable to you? ओके, सो व्हाट आई एम एक्सपेक्टिंग इज कि मैंने जैसे लिखा भी था ग्रुप में, हर क्वेश्चन के लिए एक अलग से एक फाइल बनाओ जिसमें तुम कोड लिखोगे एंड राइट कोड एंड डॉक्यूमेंट इट वेल. तो उसके बाद हम लोग उस पे उन चीज़ों पे हम लोग क्या करेंगे, वी विल डू वन थिंग एंड वी विल परफॉर्म सम टेस्ट्स एंड देन वी विल सी कि कोड पूरा रन हो रहा है कि आर देयर सम कॉर्नर केसेस जो तुमने कंसिडर नहीं किए. So and the first three assignments are sort of basic assignments. So we are not delving into some real world problem or project. So our plan is also to give the problems that occur in the industry and that do happen within the realm of academia. So हम लोग वो problems देंगे. But the first three assignments will be mostly to get your basics done, and then we'll give you 2 to 3 or till 5 projects. I think whole of this November will go into Python, your practice of Python, and then we'll take it slowly after that into machine learning models and stuff. But I want you to work hard. वो मैं बार बार बोल रहा हूँ. In the previous session we discussed about functions, तो हमारा कुछ थोड़ा सा portion रह गया था functions में. So let's start with that, and we'll close the basic Python. Then today our main discussion is Numpy library. Okay, just be active, and whenever you have questions, do ask that. The first thing is we'll start with functions in functions. So function within the function. Suppose we have defined a function. In that function, we are defining another function, and that function is these are called nested functions. If you see it here, I have written they are called nested functions. So nested function means a function within a function. As we have nested loops, that means a loop within a loop. So how do we write that? For example, if you see this code, so there is a definition outer function. So this is the outer function's name, and it takes a parameter x as an argument. Then inside that function, as you see, you can clearly see that this is the body of the outer function. Then in the inner function, we have again written some statements. So this much is the body of the inner function, and inner function computes something. And you can see here there are two return statements. So we'll go, delve deeper into the return statements as well. So now what we'll do is, if we call this outer function, if you call this outer function and call the parameter is 5, so what will happen is, so this x will get value 5. Okay, so what will happen afterwards is it will directly go here. So here is just the definition, it won't go inside, so it will call the inner function. The outer function in the inside of the body of outer function, you can clearly see there is a call to the inner function. So now this inner function will get called. So there is something called as stack memory, if you know. So when a function call happens, so हमारी memory में एक stack होता है. So for example, when we had this, तो हमने पहले outer function को call किया. Let's call it outer of x. Okay, now जब हमने इस outer को यहाँ पे call किया, you can see it went into this and it called inner function. So what happened is it will call inner function, inner of y. So you can see the stack is getting filled up. तो एक दूसरे के बाद एक calls हो रही है. These are called function calls. In the previous session we discussed on, these are called function calls. क्योंकि अभी पहला call जो है, if you see it, let me just admit these people. So if you see, the first function call is not yet executed completely. So that's why this stack is continuously filling up. So this is a stack memory if you see that. So हमने outer function को call किया. So outer function in turn called inner function. But yet the outer function has not terminated, if you see. That's why it is still in the stack memory. So what will happen is, when this inner function will be called, now return y multiply y. As we know that here y was equal to function of x, so y is also equal to 5 and x is also equal to 5. So here the return statement is y square. So y square means 25. So this function, this result will now store 25 in it. Okay, so the result value will be 25. So also the return value, now this will get popped out because now we are done with running the inner function, if you see. we are done with running this part because it has done its work. That's why in the stack memory this call will get popped up. So now the control will again go to the outer function because outer function's body in total is this much. So it executed this much. So now it will again return this. So again here we'll also get return as 25. So the output of this function will be 25 if you see it here. Is this clear how function calls are happening? For example, if there is a function call within the function call, so what I told is there is a stack that is kept. This is called calling stack actually, function calling stack. So whenever a call happens, so the stack is basically it keeps the track of everything. So first we had this outer of x, then in turn the outer of x called inner of x. Okay, till the execution of the function is not completed, it will reside in the memory till that point of time. और जैसे ही complete होगी execution, so we'll pop it out. Okay, if you know that stack is a data structure in which whatever goes first it comes last out. We call it first in last out. So for example here we can see that outer it was the first call we made, but it will be popping at the end. So this is called phyllo data structure. First in last out, or last in first out. So whatever goes last it will come first. That's why it's called stack. We are stacking some things. So if you see a stack of plates, जिस plate को हम सबसे पहले नीचे रखते हैं वो सबसे last में हम उसको उठाते हैं क्योंकि because there are stacks of plates on that. So this is called calling stack. So here we call the outer function first, and then within the outer function the inner function was called. Till the execution of inner function is not done, we will not resume this outer function's body again. So I hope this is clear. So again if you see here the similar thing is done here. So we are again calling this outer function here. So how should I? You should make a stack whenever you see calls function is calling another function. So here outer of x. So outer of x. So x here is 10 as you can see. This is function calls. So outer of x is 10. So what will happen is it will go into the body of outer function. And now in turn there is a definition of inner function. So here we have returned inner function's value. So whatever the value of inner function is, we have returned that. So inner function we are basically calling this called closure basically in Python. So here if you see that now we have y. So initially we called it with x, and then if you see we are return this inner function. So in turn inner function will call and this will sum up the value of x plus y. So initially we called 5 and then in the closure function we called 5. So the inner call will be equal to I is equal to 5, and as return x plus y, so it will return value 15. 10 plus 5 15. So these are the nested calls. So you will frequently see like a function calling a function within itself, or for example it might not be even nested. So you can see there are some functions which will go in order. Sometimes we'll have functions in order, sometimes we'll have nesting. One function will call other function inside. So I hope this nesting of functions is clear and you got the concept of this calling stack. So by calling stack I mean the computer's memory, it will keep a stack of the function calls, and whenever the function completes its execution then only it will evict it or pop it out. Then in Python we have a shorthand for functions that's called anonymous functions. If you know the meaning of anonymous, it means like something without a name. तो बहुत सारी real life scenarios में हमारे पास ऐसा होता है कि I don't want to create a function. For example, if I just want to do some computation in one line and I don't want to create a function for that. So what Python gives us is actually an unnamed function. So I can use a function without a name that time, because maybe I just will call it one time there and I want to do something. So these functions are also called lambda functions. So this is special to Python. Special to Python. So in Python, like in programming lingo, they are called as syntactic sugar. Syntactic sugar means if something is there and just we are making a syntax change, by that syntax change, and we are able to achieve something that otherwise can be achieved with a norm, but we are making some things like in some other syntax by achieving the same result. So here, what is the advantage of this lambda function? The first thing is readability. Okay, by readability it means like for example if sometimes I just want to make a one function call, at that time I don't want to create a big function by using definition, then calling name, then argument, then write the return statement. It's a lot of work. I just want to make a little bit concise, so because I'm just calling it for temporary purpose. That's why like anonymous function is mostly used for temporary purposes. It's not like you will call it call that function again and again. Maybe you'll call it 1 2 times, but not more than that. So first it will become readability, because you are not writing a lot of code, and for the people who are reading your code, it will be easy for them to read. Then it also reduces the naming overhead because you don't have to name the function. तो जब नाम ही नहीं देना होता, then you don't have to think about what name should I give, so what other things, you don't take care of that. So that's why they are not known as anonymous. Anonymous means that they are not having a name, they don't require a name basically. And then immediate execution, so you can just run them there, so you don't have to even write return statements in this. Okay, so the properties are like, you can write the properties, you can, they have versatility in arguments, and it's actually just single expression, you can evaluate a single expression in this. So, and you can also evaluate and return statement, and you don't need to write explicitly write return. Okay, so let's see how it is. Like syntax of lambda functions, you write lambda, then you will give arguments and you will write an expression. Okay, let's, for example, if we want to compute the square of numbers, so the normal way is definition, and then I'll write square, then I'll write some arguments, x probably, then I'll say return x multiplied by x. Okay, so this is the function. Now I can call this much and call it square of 5. So what will happen is it will return 25. Okay, this is a function, but I can do it a single line. What I'll do is I'll just write lambda of x and x square. That's what I mean by here. So here this is argument, and here this is an expression that we want to evaluate. Okay, so if you just call this result square of 5, it will result in 25. The same thing will happen here if you call 5 square of 5. This actually is a pure function. Now this is the usage of lambda function. This is a single line statement. So again, just keep in mind the syntax. You will write lambda, this is the keyword, then you will write the arguments that you want to get in the function, then you will write the expression, basically the thing that will evaluate the arguments. So again, if I want to see it, like I want to show the coding window. I hope my coding window is clear. So here I can show it. For example, if I run this, you can clearly see that this is computing the square. And if I want to compute the square of, let's suppose 10. If I want to compute the square of 10, so multiply here, you can see that 100. So if I even want not just compute the square, I want to compute the square and plus 3 multiplied by x whatever value plus 10. I want to create an expression of some sort. So here if I give value 10, you can just see it will evaluate it in 140. So here it is, this is your expression, this is the argument before the colon, and here it is preceded with lambda. Lambda means it's an anonymous function. Am I clear with this anonymous functions? Am I clear with this? Okay, so now we can sort of use different things, different functions with these lambda functions. For example, the first function we'll be using is a map. Okay, so if you want to create a function but you want to give it a list of arguments, right now, for example, if I have defined this square function, if you see it on the screen, so if I want to call it multiple times, maybe I'll use a for loop for example, I in range of, let's suppose 5, and then call this function 5 times. But there is a function map. What it does is it'll do basically the same thing. For example, I want to calculate the squares of all of these numbers in the list, number of this 1 2 3 4 5. So what I'll do is, so there is a function called as map. So map it takes two arguments. The first is the function itself, some function, and then comma some iterable. Okay. The first thing is a function. So here we'll create a lambda function. This basically computes square of numbers. So now these numbers, here we have a list of numbers. If you see the map, basically what it does, it will take number one by one and give these numbers to this lambda function and compute the squares and keep these squares, and then we're here typecasting it in the list. So what will happen is, so the output will be 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. So you can see the usage of map. So what map does is, so it basically, we can achieve the same thing by using the for loop. But writing a for loop, again, it'll go through the iterations and it'll be a lot of time. But you can just call a function map, then write the lambda function inside and write an iterable. Okay, so here we have an iterable is the list. So if you want to compute the squares, people are joining late. Let me again show you the coding window, and I want to make it clear so how it works. Yes, so I switched the coding window, so you can see it here. So we have a function map in here. Okay, so if I want to compute the squares, maybe I want to compute the cubes, let's suppose x square square, I want to compute these cubes. Okay, so this is the exponentiation, if you see. Okay, so if I run it, so you can clearly see now this map, it will take this function as an argument first. The first argument is the function, then we have a list of numbers, and for them it will again will typecast this after the answer. So here is the answer. We're printing it 1, 8, 27, 64, 125. So you saw by using the lambda functions with map, you can sort of make your programming easy. So what is the design philosophy of Python? Always remember that the design philosophy of Python is the ease of programming. Ease of programming. So that's why the creators of Python, they try to make it really easy for a user to code in Python. That's why they have given functions like map, and you see lambda functions are there. You see the typecasting is so easy and things like that. Then we have something called as filter function as well. It is a function like map. It also takes function as an argument, then iterable as an argument. Okay. So but what's the filter here? So for the values where we have true, because this lambda function will return the boolean value true or false. So you can clearly see this lambda x modulus 2, that is whenever x is even it will return 2 true, whenever x is odd it will return false. So for all the true values this filter function will take out these values. So कभी कभी हमें ये देखना होता है कि इस लिस्ट में कौन कौन से नंबर इवन है. Okay, so what we'll do, so हम या तो हम ऐसा करते हैं कि we'll create a function which will see कि कौन कौन सा number है जो even है. Then it'll be a lot of code and we have to iterate over all the things. That the simple thing is write a lambda function, and this filter function basically just gives true or false values. So if you see this filter function, it will give values true for the values which are even, and for odd values it will give false value. And then what will it do is, and it will take these even values. For example, 2 is even, 4 is even, 6 is even, 8 is even. It will take all these values and map them into the list. That's what filter function does. It is more or less like map in the ways that it takes a function as an argument, and then second it takes an iterable as an argument. Okay. So here if I want to segregate out the even numbers, so I can just use this lambda function which gives me the even numbers, and then I can map them to a list. So if you can see here, so the output is 2468. It is clearly visible on here. So again we have some functions called as sorted. I think I have also discussed in some previous session when we were talking about list. So this sorted, it is a function which gives the sorted list basically if you apply it on the list. So we can use that with the lambda function as well. So for example here if we have a list of tuples, so here we have tuples. Okay, so and it's a list. So each of the list element is actually one, we have a name, and probably second we have an age. So what we can do is we can use the key as the lambda. So what this function does is it will just take out this 25, 30, that's basically the second element in that tuple. So because we have a list of tuples, and each of the element in the tuple, each of the element in the list is a tuple, and a tuple has two elements. So here this lambda function, it just extracts x of 1. X of 1 means this second argument of the tuple. So sorted students, and we want to sort the students based on their age. Okay. So if you can see, this function basically takes the second argument, and this takes the list and sorted sorts them on the basis of second argument. So you can see that the Charlie came first in the sorted list because he is younger than all of these, and then Alice, and then Bob. So you can see this snippet of code. So look how with how much ease can we sort the people. For example, if we have a list of, let's suppose, 1,000 people, and we want to sort that list on the basis of their age. Okay, so in Python you can just write one line of the code to do that. Okay, so you can use their age factor as a key to sort, and then you can use this function as sorted. I hope that you got some gist of how to use lambda functions with some other functions like sorted, filter, and then we have map and stuff like that. And it'll come handy because I told you don't have to memorize these things. I'm not teaching here. I'm not teaching you to memorize things, but you should know that these things exist. Because whenever you have a need of these things, you can look up the internet and you can see what is the functionality of these things. That's why I'm trying to discuss some things. And there are other lot of functions which you can use with the lambda functions. So lambda function basically is a shorthand notation for using functions, and we saw the advantage as well. And it can be used with other functions to get really like to make the coding experience really easy. Then what is this return function? We'll have a discussion with this return statement. Let's suppose I'll write a function which is definition, and then I'll write, for example, function fun, and I'll take some argument x, and maybe I'll print this x. Okay, so if I make a function call, let's suppose I'll write function of x, let's give x value of 10, so 10 will be printed on the screen. Okay, so if I do this, so I cannot use this value anywhere. So I told you, just remember the function is like a machine. Okay, it takes input and it will output something. But if we want to take the control of this output and we want to manipulate it, we want to use it in some other functions, and maybe we'll do something else with this value. Okay, so for that there is a return statement. So return statement basically returns whatever the function has computed, whatever this machine has computed, it returns that. Basically, if you see like this, for example, if there is a factory and if it returns products to other people, so that's the return. You can have a function without the return statement even, but this return statement is there if you want to get the value out of the function. So you are doing some computation, and based on that computation you are getting the output of that function, and then you want to do something on that. Let me show it in the coding window. Okay, so here you can see, for example, and the syntax, you know, that we'll write some function name, and if you see it here, I have a definition of add numbers. Then let's suppose we have a result. If you do not want to print it, I'll just print it on the screen. I'll print the result on the screen. So here I'll print the result, and if I don't have this return statement, okay, so what will happen is there will be a function call, but the things will be printed. Okay, let me just print this. So you can see that nothing was returned. So it got, the result got printed here, that that's 8. 8 got printed because 5 plus 3 is 8. But if you see, I wanted to collect that result. So I here wanted to collect that result into some result. But as there was no return statement, because we're not returning anything, so this sum result had the value none because we did not return anything. So for returning, we have to explicitly write this return of result. So then only we'll be able to get the result. If you see now, if I run this, so you can see the sum is 8 now. So now I can manipulate this value. If I want to use this sum somewhere, for example, I want to sum multiplied by 2 or something, some result. Now maybe it's multiplied by 2, and I want to print this. So now I have the control over the values, over the things that function did. So function ने क्या किया? It did something. But if I do not write the return statement, what will happen is it will probably do the processing, but I don't have the control on the output of the function. So in order to get that output explicitly, I have to write this return statement. So that's the functionality of return. So similarly with this, so here we can return multiple values as well. So this Python, if you see, Python is, I think, the only language among the most famous language which gives you the power to actually give output as multiple results, and you can return multiple statements. So in here, if you see it in this, here we have numbers a and b, and we want to compute the quotient and the remainder. So Python gives you the versatility that you can basically do one thing. You can just give both of these as output. So what it does is, so if I see it here, so here I have the quotient as the result and remainder as the result. So when I call this function, okay, so it will give this result. So I want to check the type of the result. If I want to go in the coding window, so here I want to check that what is the type of this result and how it is storing the both of these arguments. So I want to see print type of result. मुझे ये पता करना कि कौन सा डेटा स्ट्रक्चर जिसमें ये स्टोर करता है चीज़ों को. Okay, so you can see it's a tuple. So basically, whenever you are returning more than one value in a function, so basically it returns a tuple. Okay, so tuple values are returned here. So then in this return result, so we are getting the result 0, that is this quotient, and then we are getting this result of 1, that is this remainder. Okay, so here we can also return multiple statements. So by just remember that when you are returning multiple statements, basically you are returning a tuple. Okay, then how to access the tuple? Because you can index it by index 0, 1, 2 and stuff like that, and you can take the values and manipulate it accordingly. Okay, then we have something called as early stopping, or maybe early returning, I'll call it. So for example, if I want to return early, if some condition is met and I want to return there and I want to stop, what this return does basically is, अगर तुम्हें याद हो, I just discussed the calling stack. So whenever a function call, if there is a return statement encountered, so immediately the stack call will get evicted. For example, if we call this absolute value, let's call it AV of x. So let's suppose x was -2. So here if you see, if x is less than 0, yeah, it is less than 0, so return -x. It will immediately return this and evict this call. It won't go to this return statement. So return का काम क्या होता है? It will just flush out the function call. So whenever you encounter return, it won't go. अगर इसके बाद कितना भी code लिखा हुआ है, so it won't matter कि इसके बाद कितना code लिखा है. If there is a return statement encountered and that return statement is executed, it won't execute the rest of the lines of the code. Okay, let me make it more clear. I'll write something. For example, I'll write it here. So after this return, let's suppose I wanted to write print something, print hello, let's suppose, and then I'll say a is equal 10 plus 9, something like this. Then I want to print a. Is it visible? Yeah. So what I'm here, so I am making a function call in here. So my point is that whenever the return statement is executed, so no matter how many lines of code are following it, if this return is executed, immediately the function will be evicted from that calling stack. So to prove my statement, because I have given as argument as -5 and I know that x is less than 0 will be true and return of x will be there. So now these things won't should not get executed. So we should just get the result of a result to -x. That we should get the result of 5. So let's do this. And I want to print the absolute value of, let's suppose, -5. Can you see it here? So here nothing got printed. So after this, no, nothing got. But if I give the value, let's suppose +8. Now plus, I know that it won't execute this return statement. Now the execution will go to this print hello and all the things afterwards. So just let me print it. Okay. So can you see that hello and 19 also got printed with this? So am I clear with this, what return statement does? So what am I saying is, for example, if you have a return statement, you encounter a return statement anywhere in the function. So no matter how many lines are after that, if that return statement is executed, these lines won't be executed. The function will be stopped right there. So if you remember this calling stack, so I'll call this absolute of -5, let's suppose. So the function call will happen absolute value of -5. Now I know that x is -5. So the first statement within the body of this function is if x is less than 0, that is this -5 less than 0, it is true. So it will execute this return of -5. So it will return this -5 and it will just stop the execution right there. क्योंकि return का काम ये होता है कि just stop it right there and do not go further. That's what I proved in the coding as well. If you see that the first call I made was with -5. So these things did not get printed. This print hello and 19 did not get printed. But when I made the call, let's make both the calls simultaneously. So you can see that. So in the first call, you can see that. I think it is not clear. I'll just call them separately. So if you see here, this -5, it was actually less than 0. So the return of -x, that's we got this 5 value got returned. So after that, there were other lines of code as well. But as you can clearly see that there is no output on the screen because this return statement got executed and the function was evicted from the calling stack. But if I do the same thing with the value 8, that is a positive value. So if I do the same thing with this, okay, +8 will get returned right there. But this return statement won't get executed. So lines following that return statement, these will be executed. So if I run this, so you can clearly see we got value as hello as well, then 19, then we got the absolute value of 8 is 8. So am I clear now? Okay. So what return statement does it will basically stop the function execution. So no matter how many lines of code are there, how many lines of code are there in the body after the return statement, if return statement is executed, nothing will be executed after that. So the only return will be executed and it will stop the execution. Okay. So then we have a concept of generator functions. Okay. So these are special kinds of functions in Python. So if you want to basically return something and you want to, and after that you want to return multiple things, not just once, and you want to do it multiple times. For example, let me just take an example. So here I want first to return 1, then I want to return 2, then I want to return 3. So what this generator function does is it basically is like a simple function, but the only added thing here is we'll write a yield instead of return. So we'll not write return 1 because as I told you, the return just stops the execution of function. So but I don't want to stop the execution. I want to return the value, but I want the execution to be going. मैं ये चाहता हूँ कि जो return ने क्या किया. So whenever a return was encountered, the function call basically got stopped there. So उसके बाद जितने भी statement आए, उनका कुछ फायदा नहीं हुआ. So what I want is, मैं चाहता हूँ कि these things should get returned, but after that whatever is following, the function should not basically stop right there. So what should happen is after that function execution should continue, even after the return. But for that, what Python programmers did is they introduced a special keyword of yield. So if you even see the definition, so here what I have written is I have written that generator functions can be paused and resumed. So here This is like a pause. Yield of 1, it is like a pause. But in turn, if I wrote a return statement, it will just execute and finish the execution of the function. But I just want to pause it here. I want to return 1 and then I want to pause it. Okay. So I'll call, for example, this simple generator, and then I'll collect the result in x. So if I write print of next of x, so the first thing is, let me just show it in the coding window, maybe it'll get clear. It was good that we had a discussion on the return so that you will understand this better. So if you see it, so if I run it the first time, so you see that print of this x, it was 1 because we here returned 1, but it got now paused. If we want to resume it, I'll just uncomment this. I'll again call this next of x. Okay, next is another function which is called on generators. So now what will happen is this 1 will get printed, followed by this high, then this 2 will also get printed, and then it will stop. If I run this, you can see 1, 2, 1, high, and 2, because now the function got paused right here. If I again want to run the function from there, so what I'll do is I'll call this next of x the third time. So you can see it. First call, these things got printed, then it resumed. This got printed in the second call, then it resumed again. From third call, you can see that till 3 it got printed. So if I again want to print the last line as well, so you can see clearly everything is printed now. Okay, now we do not have yield, so there will be maybe some error. So what I actually want you to understand here is that we had return. So what return did is it will basically stop the execution. Wherever return is there, it will stop the function execution. But sometimes we want the functionality to be like this. We want to return something, but we don't want to stop the execution. We basically want to put it on the pause. Then when I call it next, I want to get execution from right there. So यहाँ पे क्या है, यहाँ पे हम लोग yield का use करते हैं, not just return the things. So it can be think as pause and resume. So यहाँ पे जैसे मैंने पहली बार इसको कॉल किया, this one got printed, so it paused right there. So when I again called it, so यहाँ पे फिर ये high भी print हुआ, then it waited for next yield. So these two things got printed by the second call. When I called the third time, so it again resumed from here. So it will print hello and this 3. I hope this yield is clear as well. Is this clear? That's why the Python introduced this yield. I don't think there is yield in C, C++, and not in Java even. So this yield is just the alternative of return if you want to return multiple statements and want to just pause and resume the function. And you will find a lot of things when you do the real-time coding, and you will see how to use this real. Here we are just seeing how much tools do have in the bag. So जब हमें use करने की बारी आएगी, so we must know कि ये tool यहाँ पे है and we can use them. Okay. That's why and that's what is called as state persistence. State persistence means it basically preserves the state. Okay. So it preserves the state, and you can see storing them in the memory. Okay. So that's why you can think of generator as coded. You can read these notes afterwards. I think I am verbally saying all of this. Okay. So you can also check this example of this, how I'm using this. For example, if I want to, I have also given you an example, write a program to print Fibonacci numbers. So here this is the example I have done, but by using the yield. I don't think we need to discuss it. Then there is something called as pass by value and pass by reference. I think this is one of the last topics I wanted to cover in the functions. So what will happen is, for example, अगर मैंने एक function लिखा, so I wrote a function, definition of function, and then I wrote, for example, x. So when I call this function of 5, so this value will go into this. Okay. So sometimes what will happen is, अगर हम लोग कुछ modify कर रहे हैं इस function में, and the things that we modify, they are modified जो value हमने pass करी basically. That's called pass by reference. Pass by value is if a separate copy is passed. Okay, for example, here we have this definition of square. Okay, so what will happen is, if I have defined this square, now I wrote a number, I defined a variable 5. So in the computer's memory, 5 will be created and it will be named as number. So ऐसे ये create होगा. Then I am calling this function square with this number. So this here is basically call by value. तो यहाँ पे क्या होगा, ये number तो pass किया हमने, but its copy will be transferred. Okay, it won't be transferred as it is. So all the change that we'll be making in the function with this, it won't happen in this number. So these will be local changes, I'll say. So जब मैंने ये pass किया, तो here I got the result as 25. If I print this number before call, it is 5. If I print it after call, still it is 5. But if I print this result, it will be 25. So यहाँ पे जब भी हमने कोई variable pass किया function को, in that what happened is a local copy got created. Okay, some new copy got created, and that was actually given to this, and then manipulation were done in that copy. Okay, so you can see the original number here, number 5, it never got any change. So that's why I have written here before call value and after call value, the number basically remained the same, but this result while we returned it, it was a temporary copy, so we just stored in the result, and you can see 25. Am I clear what will happen if there is a call by value, or we call it pass by value? But what is the pass by reference? Okay, so let me check it. We have a list, my list 1 2 3. This is also a list. So what I am doing is I am making a function which appends n the number. Okay, so I am printing this list before the call. So you can see 1 2 3 got printed before the call. So after that I am modifying this list. I am calling this function with this list as an argument. So what it does is it will basically append this 41 within that list. Okay, so what will happen is after the call this list got modified. In the first case, when we called this number, and we saw that after the call and before the call the number were basically same, there were no changes applied to that number. But if you see in this list, so what will happen is before the call the list was 1 2 3. It did not make a local copy. What it did, it just passed this list to the function, and function basically appended 42 number in the same list, and the list basically got modified. So this is called call by reference. ओके ये ऐसी चीज़ है, अगर फॉर एग्जांपल कॉल बाय वैल्यू, इफ आई वांट टू एक्सप्लेन इट, सो इफ यू हैव फॉर एग्जांपल योर नोट्स, तो तुम अपने फ्रेंड को अपने नोट्स दे रहे हो एंड ही डज ऑन समथिंग ऑन योर नोट्स. सो कॉल बाय वैल्यू विल बी कि वो तुम्हारे नोट्स का फोटो कॉपी कर लेता है, एंड देन वट एवर मॉडिफिकेशन ही डज दैट ऑन द फोटो कॉपी ही क्रिएट ऑफ योर नोट्स. दैट इज कॉल बाय वैल्यू, क्योंकि तुम्हारे नोट्स में चेंज नहीं हो रहा, तो द नोट्स ही कॉपीड फ्रॉम यू उनमें चेंज हो रहा है. बट वट इज कॉल बाय रेफरेंस और पास बाय रेफरेंसेस, if you gave your notes to a friend and he's making the change, वो कुछ भी उस पर लिख रहा है and he's highlighting your notes, anything that he's changing is appearing on your notes, that is called by reference because he's not creating a new copy. So is this clear? Is this call by value and call by reference clear? So Python basically uses both of these, call by value and call by reference. It uses both of these. If you see C, C++, so in C it uses call by value, but if you want to make call by reference, you have the concept of pointers there. In the C++, I think in the Java same thing happens. So here, based on the context, it will do the call by value or call by reference. So for example here, this list was basically mutable, so it easily thought, okay, I'll do it by call by reference. So similarly in this number wala case, what it did is it did call by value. Okay, just reiterate the example. Whenever I'm passing something and that thing is getting modified, it is a call by reference. If I'm passing a value to the function and that thing is not modified because it creates a local copy, that is call by value. So Python supports both call by value and call by reference as well. But C and C++ also supports, you have to additionally write the concept of pointers in there. Is this clear? I just wait for a second, catch some breath, then we'll go on the scope. This is the last topic of functions. Last topic. Do you have questions till now regarding assignments, regarding everything that we're doing here? Am I going too fast? हाँ, sure, we'll do that. In probably assignment 3 we'll do that. I think assignment 2 will give you the specific problems on this lambda functions and these map filter. I'll urge you to read a lot of documentation. So what I'm telling you here are the tools basically. So how to be good at these tools is you just search the internet and go to the official document. Do not go to like third party websites where they write anything. So either go on trusted websites, or the best thing is go on the documentation, because documentation is usually written by the creators and they know what they're writing. So I have seen many people, for example, claiming a thing regarding one thing. When I read the document, it's actually the reverse of what they were explaining. So the better thing is read the documentation. If you want to go, for example, I'll just browse here and I'll show you how to read the documentation. So for example, today I was creating this Numpy for you. So what I did is, so Numpy itself has basically its own official website. So you can see I never read third party code. The problem with them is, so they give their own explanation. Sometimes it contradicts with the explanation that there is in the real documentation. So you can see here the real documentation, because these people, they have created it. Okay, so here they have a user guide. If you are just getting started with this, you can get started, and then they have user guide. If you want to understand more and contribute to the library, you can write it here. So I, for example, want the user guide. So what are the functions in there? So if I just can go over some, let's suppose IO with NumPy and choosing a data type, something like this. So you can see there are code snippets, there are functions, and they explain how these functions work. And they have examples as well. So the best thing that you can do is go to the code documentation and read the documentation instead of these blogs or videos and stuff like that, because this is the first hand experience, somebody has written this. So that's why if you want to get good at map filter, just write a map python documentation, because python.org has its own documentation as well. I don't want you to rely on the, that's called secondary sources. So if you are in the debating environment, so वहाँ पे वो क्या बोलते हैं कि what is your primary source of this information. So the primary source is जहाँ जो जिसने खुद witness किया होगा इन चीज़ें. The secondary source is who has seen somebody or who had heard somebody asking, or somebody जिसने किसी और से सुना है. So that's secondary source. The best thing is go to the primary sources like documentation. They have everything has an official website. So make best use of this python.org, and we'll also make sure that we give you a problem so that you also get some hands-on experience with these things. I hope I'm clear with this. Let's go to the scope of variables. This is an important topic because sometimes like this can be frustrating for the people because they sometimes get out of the scope of a variable and then see I am not able to print this. There is an error. So what basically scope means? Scope means a region of program. So some part of the program where you have the access to modify or to even, for example, read something. Or sometimes you don't have modify access as well. So what I am telling is, so what is scope? Scope is a region of program or a part of program. So because program itself has parts, if you see that we have a function body, then there is a before function there is some code, after function there is some code. The program has different regions. So where a variable is accessed, so it is called the scope of that variable. Okay, so there are a lot of scopes if you see. So the first thing is, let me just talk about scope. So this is a variable. So if it is written at the top of the file, so it can be within the file, it can be accessed anywhere. Okay, so here I have written global variable 10. So if I use global variable over here, it will get printed. If I use it after the function, it will get printed, because in the whole file, I can access this because this is written at the top of the file. So usually the placement of a variable, it decides its scope. So here I have written this variable at the top of the file, and whatever precedes that thing, so that is the scope of that. So that's why I have written global scope. Global scope means if you define any variable outside the function or a class, it has a global scope. That means it can be accessed from any part of the code, both inside the functions and outside the functions, as you can see it here. So I'll just go to the coding window to show you that what is global scope. Here we have. So we have this global variable. So within the function, I have accessed this print global, and even after the function call, I want to access this. So after this function, I also want to access this. So I'll see what will happen. So you can see out it gives me the output of 10 twice, because here within the function I can also execute it, and afterwards the function I can also execute it. But what if I just take this variable and I define it inside the function? Now I made the scope limited. I can access this variable within the function only. I cannot access this variable outside the function. That's called local scope. So if I just, for example, print this first call, my function, here it will get called and then global will be printed. So whenever I want to print global variable again, so it should throw me an error because it will say it is not defined. So basically here I have to like restart every cell. This Jupyter node, what it does, it'll basically take the previous things, and I'll say write some other thing. VARI. I'll have to rename the change, because if you know how Jupyter node works, it keeps the state. So you can see that I got the error. Variable is not defined. But the first thing is I got 10 as output first. So पहले मुझे क्या हुआ, जब मैंने पहली बार इस variable को call किया, print this variable, it was within the scope of this function. So I could call this. But the second time I tried to call it, you see in here, so it gave me the error, vari is not defined. So this is called local scope. Okay. So I explained the local scope as well. So local scope is which has the access within the function. It is just defined inside the function, and it is only accessible within the specific function. You cannot specify. You cannot basically access outside the function, that we saw. So I just made this variable inside the function, and then I tried to access it outside the function. I could not access it. So is it clear? Is this global scope and local scope clear? because sometimes you want your data should be only accessed within a function. I don't want to give access to all the functions to modify it. So for that you have to create this local variable. But if you sometimes want to create a maybe variable or some data which is accessible all the functions, for that you create it as global. Okay. Then we have also something called as non enclosing scope or non-local scope. Okay. So in that, if this is basically used in nested functions when you have a function within a function. Okay. So this is basically not purely local, not basically global. So this does not follow. This is not purely global, cannot be accessed through a file, and it is not purely local as well. Okay, so if you see this outer variable, it can be accessed with by this function as well and by this function as well. So it can be accessed by both functions, but cannot be accessed by outside the other function. So that's why this is called enclosed or non-local scope, because it does not follow global, as it's not accessible to every file, every function of the file. And it's not also local because it is not accessible to only one function. It's accessible to multiple functions as well. So you can see the code lines over here, because I don't want to delve more into these. I don't want to give you everything. I want you to research on these topics, because these are the topics which you will be using frequently, and you will be banging your head sometimes कि ये variable यहाँ पे access क्यों नहीं हो. Then you will see, oh इसका scope ही कम है, इसका scope local था. And sometimes you will feel कि variable कैसे modify हो गया. I haven't modified it, but you will see that some other function has actually access to a variable, and then the variable was global. We have a built-in scope. So what built-in scope is, for example, if you write print, you can write print in any time at any portion of the code. So you'll be access to get the value of the print. So print function has built-in scope. For example, even this length function, they have these functions which are basically built in within this, and you can write them at any line of the code, and you get access to these. So these are called built-in scopes. Like we have print functions, we have length functions, then we have some other functions like that. They are called built-in scope. I think the concept of scope is clear. I haven't dwelled much into this with this scope, because the scope itself will take 1 to 2 hours to explain you the every nitty-gritty details of the scope. So I want you to do a little bit of research about the scope. Go to the official documentation, what is the scope, and try to do different examples. I will also try to include some assignment questions based on the scope, so that you get well versed with the scope. So I haven't discussed in detail, but I hope that at least you have the concept of scope clear to some extent कि scope होता क्या है. Scope means कि कौन सा वेरिएबल या कौन सा मेरा जो मेमोरी लोकेशन है वो कहाँ किस पोर्शन में एक्सेसिबल है. So we saw global scope, we saw local scope, then we saw enclosing scope, we also saw something as called as built-in scope. So these are only 4 types of scope, but you need to do a lot of practice in order to thoroughly understand them. Okay, so here we are done with basic Python. Done with basic Python. So you have every tool in your toolbox by which you can do anything now, but you have to work hard, practice. Okay, so I'll just tell you upfront what are the projects that are coming. The first project we are designing for you is you will make basically a to-do list. So what is the to-do list? So you will you know that you want to do time management, and for that you have a task of you have a list of tasks, and sometimes you want to do them today, and if a task is done, how much is it done. So based on the complexity of your code, in that, like, you can build on this project. Initially you'll do a basic to-do list in which you can add tasks and remove tasks and things like that. And the second project that we are thinking is you will make basically a shopping calculator. So if you are, for example, working on Flipkart or something, so you add products in your cart, then you see if there is a discount coupon applied, and then after checkout there is an 18% GST charged for you. So all of these consider you have to do, and you will make a shopping calculator. It will basically a part of maybe online some website. So this will be a part, and here you will make this. This will be your second project. We are working on this, and we're also working on this. So these two projects we have finalized as of now. Okay, because now you are done with this basic Python, I think these two projects you can easily do. तुम एक कंसोल पे बना सकते हो एक टाइम मैनेजमेंट वाला टूल, जिसमें तुम लोग रख सकते हो कि टास्क कौन कौन सा ऐड करने हैं, कौन सा टास्क रिमूव करने हैं, और किस टास्क को कितना टाइम देना है, थिंग्स लाइक दैट. एंड यू विल हैव काउंट डाउन टाइमर्स हियर इन द शॉपिंग एज वेल. फॉर एग्जाम्पल इफ देयर इज अ फेस्टिवल सीजन और थिंग्स लाइक दैट, तो ये कूपन कोड अप्लाई करने पे इतना डिस्काउंट लगना चाहिए इफ़ यू हैव अ परचेज ग्रेटर देन दिस, things like that. And then at the end of you have to print the bill of the items के इतने items लिए and इसको 18% GST लगा, total billable amount is this much. So these are two projects. Finally, as of now, we are thinking of other two projects, but for that you have to do your, I think, 3 assignments: 0, 1, and 2. So these will be basic assignments which will just brush up the basics. that we have studied, and after these basics are done with you, then we can do this modularization code, and we can make 2 3 projects on Python. Then we'll wrap up Python, and then we can also move into this machine learning and stuff. Am I clear with this? That's why doing these assignments is really necessary. If you do this assignment, then only will you be able to make these projects, and we want these projects console based for now. हमें नहीं चाहिए कि you will make a UI and things like that. And if you still want to go on with these, you can add the complexities on the code, and you can make it a UI based code. Then probably add some more things, and this can be integrated in a shopping market or something like that. So I hope that first you will do it for the purpose of project, and then if you want to continue it, you can keep on doing the thing. And there are a lot of applications which have this to-do list, and nowadays people are using apps for time man. Even I am using apps for time management. So for example, if you can make a real good progress on this, it can be made as an Android or some app as well. Similar thing for this. Even we can, for shopping purposes, we can just scrap the web like Amazon, Flipkart, and things like, and we can compare the price of these products, and then we can see what are the coupon codes available online. We can search through the online and see and give the best price. And this can also be made an app. You can also create an app of Android, iOS, or Windows app. So the idea here is to make a time management app. The idea here is to make an app which compares the different prices throughout these. For example, if you have a product, let's suppose iPhone, and you want to purchase it, but you want to see कि Flipkart कौन से price पे दे रहा है, and then कौन कौन से offer है, and you want to see Amazon किस किस price पे दे रहा है, and you want to see the what is the lowest price और कहाँ पे मिलेगा ये, and then you will also search through coupons because there are directory webs of coupons, और उनको search करके कौन सा coupon code अच्छा लगेगा इस पे, and then you will see कि सबसे minimum bill कैसे मैं create करूँगा out of this. So this basically is a problem of shopping. So here we'll make a time management app. So these are 2 things as of now, and you can build on them. Okay. Now we are wrapping up with Python. So now we'll be starting the different libraries of machine learning. I think this is the Numpy. Huh. Do you have some questions? So I'll take some questions and take some water. Okay. I don't think you have a question. Let's move on with the. Yes. Okay. So let me start. Why are we reading about ML libraries? So we'll have a brief discussion about this so that to put things in context. So मैंने बोला था if you want to achieve a thing, there is a pipeline, there is a whole workflow. हम लोग कैसे जा रहे हैं? The first thing is we learned a language. So now we have access how to talk to a computer, how to talk to these machines. कि अगर मुझे कोई काम कराना है machine से, now I understand their language. The first barrier was this. So we have crossed our first barrier, but we need to get an expertise with this that you will get by doing the assignments and by solving the project. And now afterwards, now I have a language, but I don't want to reinvent the tools. अभी बहुत लोगों ने बहुत सारा काम किया हुआ इन चीज़ों पे. They are really efficient at it. It's like कि मुझे एक नई कार बनानी है. I won't make the wheel because wheel is also there. I just want to modify it. So for that, people have written some good code. Okay, that good code went and these are huge codes, huge code bases. So we call them libraries. Okay, so we have modules in Python first. What is a module? So module is anything that contains Python code. So if you have 2 files like this and there is some Python code, I can call it a module. For example, अगर तुमने कोई calculator बनाया and you added some function, for example subtract की एक function लिख दी तुम लोगों ने, add की एक function लिख दी, multiply की एक function, you wrote a lot of functions. Maybe I'll call this a math module कि हमने एक module बनाया math के लिए because it has Python code in it and it does some mathy work and it does some math functions. Okay, so if I put different modules together, maybe I have some math module and some other thing. For example, let's suppose I'll make some other module. What it does is it calculates maybe simple interest, and then it also calculates suppose investment return on investments. Some functions are there. Then this is module 2. Okay, so I have such n modules. Let's suppose. So what I did is I'll wrap all of these modules together. I'll make a big thing that's called a library. So अगर मैं इसको simple example में समझाऊँ, so for example if you write a book, so book में can be on any topic. You write a book on programming, some other people wrote book on history. So these books are like modules. So there is a lot of modules. When we put all of these books together in one place, we call that a library. Okay. So similar with the Python, you write Python code, and then with that Python code you will add a lot of function, a similar functional. You will make some module out of it. When you combine a lot of modules, so you will make a library. Now I hope that this concept of modules and libraries is clear कि library का क्या मतलब होता है कि और module का क्या मतलब होता है. So in the definition, if you see that I wrote that modules are files containing the Python code, and while libraries are collection of modules. Okay. So what do we do is कुछ लोगों ने बहुत अच्छा code लिखा होता है and we want to reuse that code. So I'm again going to the big picture. So हमारे पास अब language है, but there are some really great people, really good coders who have written some code, and we don't want to reinvent the wheel and we want to reuse their code. So for that they have created libraries. So उनने अपने code को libraries में convert किया है. Okay. The library has bunch of modules and it has a lot of code in it. We just want to use that code. How to use that code? Now we can use import statements. Import. So it's like, for example, you want to take something out of that tool. So you'll write import module name, and you'll see. For example, if I want to import, and if I want to use functionalities of pandas, I'll write import pandas. That means like give me the functionality wherever this code base, it will be located somewhere in your local machine. Then I want to import the functionalities of pandas. Import numpy. Okay, numpy is a library basically. So I want to import that. And as PD, these are called aliases. I don't want to always write pandas. I just want to write PD. For example, some of you have nicknames. For example, I'll say Amir. Suppose some people call him Ami or something. So that's an alias because sometimes it's a bigger name and we call it by smaller names. So pandas, we have scikit-learn and things like that. For that we call them with aliases. So here you can see that we imported pandas as PD. As PD means I won't call it pandas now on the code. I'll just call it PD. Okay. What import means is import means give me access to the functionalities which are there in this pandas library. Is module clear? And is this concept of library clear? And is the concept of import and aliases clear to you? Okay, because we'll be writing a lot of import statements, because we will not be reinventing the wheel. We'll be continuously using some code written by other people, and you will also create your own modules. So maybe at the end your goal should be कि क्यों ना मैं खुद की एक अच्छी library लिखूं ML के लिए. And I had people in the first year of BTech, and they wrote these libraries. They wrote whole ML libraries themselves. And this is not an ambitious goal to have. It is easily achievable. If you have dedication, you can make a good library which people will use. So you should also have this in mind कि मैं इतने modules लिखूंगा, I'll put these modules together and I'll make a library out of these so that other people can use my code as well. Okay, so let's now go to NumPy. So what is NumPy? So it first thing, it is a library. Okay, it's a library. And what is this library used for? It is used for scientific computing. Okay, it's used in numerical Python. By numerical I mean because in scientific computation we deal with a lot of numbers. So in that we have some people came together and they make a library which basically deals with this computation of things for like linear algebra and stuff like that, and statics. There are a lot of functions. We'll go in that. It provides really powerful, that's called as multi-dimensional array objects basically what it provides. So we'll see कि हम लोग numpy use क्यों कर रहे हैं. If Python already has lists, तो list भी वही काम कर सकते हैं. NumPy is not anything new कि ये कुछ खास करके देता है. The things that a list is capable of doing, I think most of the things NumPy also does that. So वो हमें देखना है कि वहाँ पे कौन कौन से फर्क कहाँ कहाँ पे हैं. The first thing is NumPy gives you the fixed size. We call them n-dimensional array objects when you call them. Unlike Python list, we saw that Python. If you have done your homework, I told you go and do some homework on Python lists. So you will see that in list Python lists are dynamic, so they grow dynamically. There is no fixed length. But in this we have fixed length. Then we have homogeneous data. By that I mean as you know that lists can have multiple data types. For example, a list can have an integer. Then we can write hello. Then we can write suppose 1 point a float number. This is a list. But in ideal scenario for this NumPy array, you cannot have heterogeneous elements. You need to have homogeneous elements. Either all should be strings or all should be floats and integers. You cannot have heterogeneous elements in that. Some advanced we have advanced features in which we can like sort of manipulate this, but speaking at the core level, NumPy only supports homogeneous element arrays. Then we have efficient operations. This is the most important thing. Why do we use these things instead of, why do we use NumPy arrays instead of the lists? Is because this numerical Python library, it has been optimized. If any of you knows compiler design, there is something called as code optimization. So we want our code to run really faster. Look, Python is really good. It's really easy, but it's really slow. If you compare the code in C and compare the code of Python, maybe C is nearly 100 times faster than Python. Python provides everything good, but it's really slow. So if I have to do some computation, it'll take ages. So for that, people thought, if some people are doing scientific and they want the best of both worlds, they want the speed and they want the simplicity of writing the code. Let's create Python. Okay. So if you see, for example, if I want to create a list, like we have a list A and B, I want to merge these two lists together, for example, let's suppose, or I want to multiply these numbers, 1 multiplied by 4, 2 multiplied by 6, 3 multiplied by 5, and I want to do it in the list. So I can do it in Python. So if you see in Python, this is really easy. I just wrote a for loop and wrote c.append ai multiplied by bi. So I got the output as this. Okay, but this is really slow but easy to write. Easy to write. If you want to do achieve the same thing in C code, so C code you can achieve it like this: for I is equal to 0. This is some sort of cryptic looking code. If some people are like foreign to C, they might like, oh, this loop is even difficult. So what am I doing this? I have to access this integers, like there is some indexing and things. Like this is critical, but this is really fast. Okay. So what I want to merge both of these. What I want to do, I want to merge the speed of C and I want to merge the ease of writing of Python. That's what creates NumPy. So in NumPy, you can write in Pythonic style and you can just multiply these numbers and you will get the same result. It will be really fast. Okay. So अगर हम C language को देखें, C is fast, but it's difficult to write and there is a lot of overhead involved. So if you see Python, Python is really easy to write, but the problem it's really slow. So if I want to create a thing which has best of both the worlds, that's how NumPy arises. Okay, that's why I'm saying why to use NumPy. That's why I have wrote the first point is efficient operations. The operations are faster because this NumPy is basically implemented in C, and there are optimized functions. And if somebody says what is NumPy, NumPy is written for efficiency, and even memory efficiency is also there. Not just speed, it does computation faster. It also takes less space. Okay, memory wise also. When we speak about computer efficiency, so we speak about two things. One is called as time complexity and another is called space complexity. By time I mean how much time it takes, and another thing is how much space it takes. So both space wise as well as time wise, NumPy is faster than the other methods that are in Python. Then we have optimized functionalities as well. Okay, NumPy provides some core operations. For example, if you have matrices and you want to multiply them, you want to do certain operations on them, and we have optimized these operations. Okay. Then another thing is it's interoperable or integration. You can easily use it with some other libraries. For example, Matplotlib, Panda, scikit-learn, SciPy, and other things. And you can also integrate it with C, C++ code. The first thing is it's efficient in terms of memory, in terms of space. It has optimized functionalities. It is also interoperable. That means like interoperable. That means I can also like use the same code with the other libraries of Python like Matplotlib, Python. I can also integrate the same code in C, C++, and then it makes really easy this data analysis and manipulation of the data. So this is why this library is, I will say, heavily used. Like most of the times when you have some numerical computation, I'll say 95% of times machine learning scientists, the people who work in this academia in computing and stuff, they will use NumPy. Okay. Let me show how much fast it is. Okay. Let us go to the coding window. I'll show you how fast NumPy is. Is my coding screen visible? I hope it is. Let's go to this NumPy because this session 6 is done. There is a function called as timeIt. So I have a list L, and you know that what range function does it. Range function will create these 1000 elements, and I want to square these elements. This is the concept of list comprehension. So let's see how much time will it take. It is going until you saw that at an average it took 250 microseconds. Microseconds means for per operation. Okay, if you know a little bit of stats, the 250 microseconds means 250 into 10 to the power minus 6 seconds basically. So these microseconds per minute, and this is called standard deviation. We'll see that what it means. So this is by using the normal list in Python. If I want to use the array, so I'll do the same thing by using NumPy arrays, and you will see how faster it is. So here NumPy is not defined. Let's first define it because we have to import it. So I'll say import NumPy, as NP. That's why I'm writing here NPA range. We'll see what this means. So I just want to time it. I want to see how much time it takes. So you can see how fast it is. It's 1.4 microseconds. Look here, it was 250. It's nearly like 200 times faster. They are basically doing the same thing. Here we are doing the same thing. We are squaring the numbers, and in the first case, it took 250 microseconds per operation. So here it took only 1.4 microseconds per operation. So is this clear how much fast it is? Okay, so NumPy is really fast. That's why we are using NumPy arrays instead of lists that are in Python. So why is NumPy fast? That there is a question. The first thing is the code is implemented in C. So there are two very important properties that NumPy has that makes it really fast. The first thing is called vectorization. Okay, so what is vectorization? Without writing explicit loops or indexing and things like that in the code, we take advantage and behind the scenes we optimize and pre-compile C code, and but we don't use loops. So if I again go back to the window, coding window, you can see that in the first thing we wrote a list comprehension, a for loop is here. If you see in the Python, a for loop is here. But here we don't see a loop. I just said a square 2. This is called a vectorization. Vectorization means I don't use loops explicitly. Okay, here I use loops explicitly. But in NumPy, the loops are not used explicitly. So there we have pre-compiled C code which does the computations really faster. Am I clear with this? What is the meaning of vectorization? Because we don't use loops in there and we don't do indexing, the operations become faster. Okay. Then the second, and you can write what the other advantage of vectorization. I think like reduce potential bugs and things like that. And second thing is broadcasting. And I'll cover this broadcasting at the end because for that you need to have an understanding of the arrays. Okay. Broadcasting and vectorization are the two main things that are there in the NumPy arrays that make it really faster. Okay, because and the core reason is because all of these things are having pre-compiled C code at the back end. Okay, and we'll see what this broadcasting means, and at the end I have an example for that. Let's go with the basics first. Okay, let's see what is the meaning of an array first, because this array, it serves as a fundamental data structure. It's a fundamental data structure. It is basically a grid of values if I see it. So why is this arrays important? ये arrays को हमने इतना क्यों सर पे चढ़ा रखा है कि these are so important? Everything basically which is there in our computer, it basically is a number. It is a bunch of numbers, nothing else. So if you see my image, so what image is? It's a bunch of pixels. Okay, you might have seen कि अभी हमारे पास क्या है, हमारे पास होते हैं 1280 मल्टीप्लाइड बाई 720. तो ये बेसिकली एस्पेक्ट रेशो होता है कि कितने पिक्सल्स है इसमें. इफ यू सी इमेज वी हैव, अगर बहुत ही घटिया इमेज है 3GP वाली इमेज, तो 20x8 पिक्सल्स आर देयर. Okay, so what are these pixels? These pixels basically are numbers. So these numbers represent, so each pixel is represented by 4 numbers if I see. So red, green and blue, and then we have something called as opacity, as transparency. ओके, तो रेड कितना पार्ट है इसमें, ग्रीन कितना पार्ट है, ब्लू कितना पार्ट है, और कितना ओपेसिटी है इसमें, कितना ट्रांसपेरेंट दिखता है. तो दीज 4 numbers define a pixel, and a bunch of these pixels, it defines an image. A bunch of pixels defines an image, and when we have a bunch of images moving with the audio, we call it a video. So do you see how much beautiful it is? Numbers are so beautiful. So we have numbers, we have 4 numbers representing a pixel, and then bunch of these pixels, we call them an image, and then bunch of these images, we call that a video. We call that a video at mute. But when you put the audio, and audio itself, it basically is a number. So audio में क्या होता है? We have something called as spectrograms. So if you know that, there is something called as waveforms. These spectrograms are made out of these waveforms. So waveforms are just not, but just like the amplitude, and this amplitude is they're described by using numbers. Behind the scene, everything in your computer is a number. No matter what it is, if it is a game, it's a number. If it's anything, it's a number. So if it is your data, it's a number. Okay, anything in the computer is a number. That's why we have to perform computations on these numbers. So when you even walk, जब तो हम लोग चलते हैं तो we make computations. Our brain makes computations कि कौन सा कदम कितना लेना है. So if you are walking on a stage, so what our brain does is we calculate the distance of my stairs to the next step, and then we see how hard are the stairs कि कितना पाँव जोर से रखना है, and then I see how much force to apply and in which direction I should put my feet. All these calculations are made by our brain, and we don't even know them. That's why they are called giant computers. Our brain is a heavy computer. It computes a lot of stuff. Okay, so everything behind the scenes is basically numbers. That's why we manipulate these numbers in order to achieve anything. ये वही रीजन है हम लोग इस numpy को इनको अलग से डील करें. That's why these arrays become so important. So what is an array? So what I told is array is basically a data structure. It's just a grid of values. Okay, and then we can have the types of data, and we can have numeric data types like int, float, strings, and things like that. Okay, so what are some key features? So it is indexed. Okay, so what is the meaning of index? So if I create an array, it's 1 2 3 4 5, something like this. So the index is 0 1 2 3 and 4. I also discussed indexing in the last session. I think here it's important again to look at this. We have negative indexing as well: -1, -2, -3, -4, -5. Do you see concepts repeating? That's why I want you not to memorize. Should not memorize, because if you have a concept, it gets repeated somewhere. तुम लोगों को पता है इंडेक्सिंग कैसे की जाती है? You will apply same in the lists. You will apply same in the this numerical Python arrays. You'll also do same with the tuples and things like that. But if you know how this indexing works, okay. So basically, the first thing is they have an index. Then we have something called as rank. Rank means how many rows, how many columns are there. Okay. So it basically specifies that they are called dimensions. So if I say there are things like 1D things, there are something 2D things. If I draw a line, this line only has a length. It has like nearly negligent this breadth. So I call it this is 1D figure. If I have a plane with me, some rectangle or maybe some trapezoid or something like that, it has length as well as breadth. So its dimension is 2. Then we have something 3D. 3D means like for the humans they have length, breadth and width as well. So if you see cube, if you see mouse, anything that you see mostly is basically a 3D object. Can you give me example of 2D objects without like some physical objects which are pure 2D? Are you sleeping? Okay. So I want you to give me some examples of 2D things. चलो पहले 3D से start करते. Give me some examples which have 3 dimensions. Like let me start. This pencil that I have with me. So it has a length, breadth and width as well. क्योंकि ये 3 dimensional object है. And I'll say this keyboard as well. The keyboard I'm typing on, this also is a 3D object because it has length, breadth and width as well. So are there some things which are 2D? जो real 2D है, जिनकी zero thickness है, बिल्कुल zero thickness, they have length and breadth as well. So can you call out a name? कौन सी चीज़ ऐसी है जो 2D है, pure 2D? Nice, nice. So here we don't have a thickness in that. We just have a length and breadth. The beautiful physical example is a shadow. Shadow की कोई thickness नहीं होती. It just has length and breadth. I think 1D things are really impossible to get because they only should have one dimension. They shouldn't have no thickness, no width. So here what I'm saying is by dimensions I mean the array can have rows, columns, okay, and array can be stacked on each other. So that's the dimension. So for example, if you see this, so it is just one row. Okay, its dimension is 1 cross. Suppose 1 cross how many numbers are there? 1, 2, 3, 4, and 5. So 1 cross 5. So this is the dimension of this array. So if you have a 2D array, we call it 2D array like this. Let's suppose we have 3 rows, 1, 2, 3 rows, maybe 4 rows. And then we have 4 columns as well. This is 4 cross 4. The dimension of this is 4 cross 4. Okay, then we have 3D arrays as well. We'll see them. That's what is the meaning of rank. Rank in mathematics is something different, but here I'll use rank. Basically, I'll use dimensions. I will not use rank. Okay, and there is a function shape which will tell me the dimension of that. This is a 1D array. If you see, so here we have a bunch of numbers 7, 2, 9, 10, and this is 1D. It just has one row. Okay, and sometimes in scientific this is just called a vector. It's not even called a row. This is called vector. It has just one column. We generally write it as 2 9 7 2 9 10. Okay, something like this. This is a 1D array. Okay, so 1D array is sometimes called as a vector. Then we have a 2D array. 2D array has a length as well as breadth, and in technical terms we call them axis 1 and axis 0. So here we had axis 0 only. So now we have two axes. So this is called 2D array. Okay. Then we have something called as 3D array. It has axis 1, axis 2 and axis 3. Basically length, breadth and height. Okay. So this is like for example our cube, our cuboid and things like that, and basically the 3D. And we have ND arrays. because we are restricted by our imagination, so we cannot imagine more than greater than 3D. We can just imagine till 3D. 4D, you don't know how it looks. Maybe in numbers you can see it, but 4D can't be imagined. So am I clear with this? What is a 1D array? What is a 2D array? What is a 3D array? So 1D array is called a vector. Is it clear? Okay. So what is this axis and dimension? So axis, I told you that, for example, this is called axis 0. For this is axis 0, this is axis 1. Here this is axis 1, axis 2, and axis 0 is right this. These are called axis and multi-dimension arrays. Okay, and there are some key attributes that we'll see. What are some key attributes? So before going in that, let's go to how to create an array, how to create basically arrays. Now we know what are arrays. So okay, the thing is, I want to see how to create these arrays. Okay, the first thing how to create an array is I can just have a list of numbers 1, 2, 3 like this, and I can create a numpy array out of this. And there is a function as array. You have to write array and this enclose with this, and this preceded with the np dot. Np means this is I am using a function array which is located in numpy module, numpy library, and I want to import that, and you can assign it to a. Let us do it in the coding, and I'll show you. Here it is. So if I want to create a list, let's suppose list is equal to a list 1 comma 2 comma 3. Oh, screen got switched. Okay, so then I want to convert it into, suppose, list. This is list because list I think is somewhere used. तो मैंने यहाँ पे इतना लिखा. So what I'll do is I'll first type print करूँगा मैं ये list का type क्या है. Print type of this list. So obviously because it is a list, so the list should get printed. So here you saw that it is from class list if you see it here. Okay. But what if I want to convert into Python? So there is a function np.array if I write it here. Okay. So here I'll just call this list, and I'll now see this type of this a. Print type of a. Now you can see that this is numpy nd array. So we had a list we converted into by using the function np.array. Okay, initially it was list, now it will be treated as numpy array. Okay, so this is how we create lists. I showed you just a simple example of how to create these numpy arrays. Okay, so how many ways are there to create the array? The first thing is conversion from other data structures. So we have list, we have probably tuple, we have other data structures. If I want to convert them and make them numpy array, that's the first way of creating a numpy array. So there are 6 ways. How many ways? 6 ways. So first I understood what are arrays. Now I want to see कि कौन कौन सा मेथड है, किन किन तरीके से मैं इसको क्रिएट कर सकता हूँ. The first method is that if you have a list, if you have a tuple, you can create arrays out of these data structures. That's why I have the first method is conversion from other data types. If you see it here, conversion from other Python data types. These data types are sequence. For example, they are sequence, and it's really straightforward. There is a function, and we'll see it one by one. And then we have some intrinsic numpy array creation functions. So there are some functions by which you can create intrinsic numpy. Like there is function called as arange, np0s, np1s, and we'll also see that. The first method is that we'll have some sequence list like list, tuple or something, it's sequence data types, and out of these we'll create numpy arrays. The second method is we have some functions. By using those functions, I can create these numpy arrays. Then I have some other method called as replicating, joining, or mutating existing arrays. If we have existing numpy arrays, we can create new arrays out of them by just either copying them or doing some manipulation over them, mutating them basically. So that is the third method. Fourth method is if you have some data which is like of type numbers or something, and you want to read that, and you can read that in terms of numpy arrays. So you have some number list. For example, तुम लोग बैंक में काम करते हो, and there are a lot of numbers कि इसका closing balance, opening balance, पिछले साल का इतना balance था. All these things are numbers. So you want to read it as numpy array. So you can read also. You can do that also. Again, we have some other functions, for example, np from buffer, np from toString, something like that, where we can create array from these raw bytes. Then we have other special library functions from numpy by which we can create arrays. So there are 6 methods. तो ये 6 मेथड के बगैर कोई मेथड और नहीं है बनाने का. Why am I so confident? Because this is written there in the official documentation. The official documentation is like the people who have created this, they know कि हम लोगों ने इतने method बनाए हैं array creation के. I discussed each of the method कि पहला method कौन सा है कि अगर हमारे पास data structure already है, जैसे list है, तो we can create a numpy array out of that. Second method is we have some intrinsic numpy array functions which you can call, for example np.range, np.zeros and things like that. Or if we have some other arrays, we can replicate, manipulate them. Other thing is if we can read from the disk directly, अगर हमारे कंप्यूटर में कोई फाइल पड़ी है and we want to read it as numpy, we can do that. Then we can create arrays from raw bytes, okay, from to string, and there are methods and then we have special library functions as well. Let's go one by one कि कैसे चीज़ों को create किया जाता है. Let's go with the first, how to create this Python sequence to numpy arrays. If we have a sequence of if you have a sequence data type like list, how to create numpy array out of this. So as you saw that array can be 1D, 2D, or let's say greater than 2D, we call it higher dimension arrays. The first thing is, let's suppose we have a list. This is a list 1, 2, 3, 4. It's a list. It's a 1D list. Okay. So what we can do is you can just call this np array function, and then you can store it to a1d and array 1D. If you have a 2D list, 2D list is like this. 2D list basically you can write for your memorization 1, 2, 3, and 4. It is like this. Matrix sort. If you want to see this 1, 2, 3, 4, it's like this 1, 2, 3, 4. Just a column vector. Then we have 3D arrays. How 3D can be processed? Like we have the first frame and then and the second frame. You know, एक दूसरे पे stack किए हुए. We have 1, 2, 3, 4, 5, 6, 7, 8. So this is a 2D array. This is a 1D array. So initially, if we have them as lists, we can just use this np.array function to convert them into lists into respective arrays 1D, 2D, and 3D. That's the first step. Okay. So let me show it in the code as well. I think this is pretty much clear. This is not that hard. Just so you can see it over here. So if I just print this, you can see that for the first A1D we have this 1D array. If you see this, then we have this 2D array. Then we have the frames. Just you have to remember, just count the number of brackets. Okay, what arrays are basically, they are lists of lists. Well, like 2D array is a lists of lists, and the 3D array is list of lists. Okay, so there are basically two ways of looking at these things. The first thing is, अगर मेरे पास एक array है, so if it's a 1D array, it's just a list, or just, for example, it's like this. If I have array of arrays, I can look it in two ways. Array of arrays means कि हर एक element खुद में array है. This is called array of arrays, or maybe let's call it list of lists. This is one way of looking at it. And the second way of looking at it is like this. These basically are equivalent, just two perspectives of looking at the same thing. So if we have 3D array, we can look at it as list, of list, of list. हर एक element खुद में एक list. Otherwise, you can just see it like this, and then you have just stack these things over. These things are equivalent. So do you see how there are two perspectives? मैं ऐसे भी देख सकता हूँ, list of lists, ऐसे ही करके देख सकता हूँ. Otherwise, I'll just stack them together. जैसे मैं यहाँ पे rows को stack किया पहले. Okay, then I had these 2D arrays, I stacked them together. Basically, they are equivalent. Looking at these things are equivalent. So this is the first way of creating arrays from the list. Now you also want to control data type. Okay, because this numpy, it provides us a lot of data structures. For example, you can have int 32, you can have float 64. So why are they different data types? Because they occupy different amounts of space. Occupy different amount of space. Am I clear with this? So for example, now if you want to control this, I want to create this 127, 128, 129. So let me just show you some magic miracle maybe to get one more concept through. So if I write this without data type int 8, okay. So what should be the thing that should get printed on the screen? If you are able to see the screen, here we have three numbers, 127, 128, 129. So what should be the output of this? I am printing A. Basically, first I am creating a numpy array, then I am printing it on the screen. So what should be the output? Beautiful. If I just press it, you can check 127, 128, 129. Okay. What if I just type this data? I'll write maybe int 32. So what will be the output now? So int data 32 means basically these are integer numbers. What should be the output? Like, it is really easy. Riyan? Yes. Right. This is 127, 128. Now, if I just change it to, let's suppose, 8, what will be the output? Zahid, Amir, Riyan, Zubair. So, what should be the output? Huh. Nice. It is for 128, it is minus 128, and for 129, it's minus 20. This is something called as overflow. So, if I write it on the screen, so where is my screen? This is something called as overflow. Okay, why is it so? Because we have limited number of bits. So as I said, that numbers are represented in 2's complement computers memory. Okay, so if you have here, we had int 8, that is we had 8 bits of memory. Okay, so 8 bits means the first bit will be reserved for sign, then we have only 7 bits. So how many possible values of 7? 2 to the power 7. Okay, that is 128 types of number, but starting with 0 to 127, it is able to represent this range, because it's only able to represent 128 numbers. So from 0 to 127 it is able to represent them, because we have only 7 working bits. जैसे हमने 128 लिखा, something happened, overflow occurred, क्योंकि अब हमारे उतने बिट्स ही नहीं थे, it changed the bits. So इसने ये वाले साइन बिट चेंज कर दी इसकी. Then we got the number as minus 128, then other was minus 127. So this is unexpected behavior, this overflow. Let me tell you an interesting story what happened with the overflow. You know कि पहले कंप्यूटर पहला जो एयर क्रैश हुआ था ना, that happened because of this overflow. The computer program लिखा गया, it was for I think Boeing 787, so it was the Airbus's name. So what happened, they have wrote this program and the register size I think was 8 bits that time. Okay, so they were using some counter to measure for example 0 to just 127. So but the same computer program was used for other machine where it shooted out, it went from 128, 129. So because of this overflow, this number got minus 128, got printed out of this 128. So what happened, its main engine shut down. So there was a crash, it hardly survived for 8 seconds, and I think that it was nearly like 10 million or so, even greater than 10 million loss was there for the company. So just one program mistake costed a company greater than $10 million. Think about this. And this was just by the problem of overflow. This is a famous case study. That's why right now when we write something, we have to give proof that this thing will work. And the problem occurred. So there was an X-ray gun made for these cancer patients. So जहाँ पे जिस portion में cancer था उसमें X-ray shoot की आती थी. So what happened actually there is, due to again this computer programming error, so what happened is वो gun ने overshoot कर दिया. Instead of curing patient, it killed the patients. That's why we need good programmers जिनको पता होगा कि हम लोग क्या चीज़ें कोड कर रहे हैं. They should not be like कि ठीक है यार हमने integer 8 declare कर दिया, it's okay. You know there can be $1 million of loss can be for the people, and there can be loss of lives. जैसे कि डॉक्टर के पास लाइफ है, एंड ऑल्सो इफ यू आर इन अ प्लेन, दैट प्लेन हैज बीन प्रोग्राम्ड बाय सम कंप्यूटर साइंटिस्ट. इफ ही इज नॉट अ गुड कंप्यूटर साइंटिस्ट, मे बी योर लाइफ इज इन डेंजर. If you are working on some equipment, for example in the hospital, and that has some programming in it, and if he was not a good programmer, maybe underflow, overflow, some bugs will be there, and instead of curing the patient, it will be killing the patient. So that's why I want to introduce overflow, underflow concepts like that. So whenever you are allocating memory, you must know what's going on under the hood. It's not just okay to be a programmer. You have to be a good programmer and know what should be happening. And this is really like sometimes buggy, and you write something like this and you expect the things will not go over 120, 127. So then you will see 128, 129, and they'll be read in computer as minus 128, this as minus 127, and things like that. So you'll have to be really careful when you assign data types to these. Am I clear with this? Huh, it will not happen. For sure it will not happen. If my computer science knowledge is right, it will not happen. So I'll just go. So int 32. First thing is we want to keep it 16, huh? So you can see, because now there is no overflow, because now we have access to the power 15 bits. We have 2 to the power 50, a range of 2 to the power 15 numbers. That is, one bit is for the sign, and rest of 15 bits are for the storing of the number. So इसलिए हमारे पास वो values वही हैं, 127, 128. I think 2 to the power 15 is I'll say 6. How much is this? 2 to the power 15. No, it's 2 to the power 10 is 1024. Let's use Google. Let's use Google. We'll directly use Google. Let's suppose we'll say 2 to the power 16. How much is this? So 2 to the power 16 is 65536. So we'll just copy it and we want to represent this number because I know that range is from 0 to 65535. So if I want to get overflow, so I'll just write this number over here. I'll definitely get overflow. Voila, you see that here we got 0. This is overflow. Okay, did you see the overflow in here? I wrote 65536. So when I run it, so you can see that 127, 120, and then 0. Because now 16 bits cannot basically have this 65536. But if I write 65535, then it will be able to accommodate them. The answer should be okay. I think not even this. I think range is little bit even less. Whatever it is, like there is a range. So it will. So if I write 32, so it will be easily you can calculate that. So I hope that you got the concept basically. तुम रेंज खुद से कैलकुलेट कर सकते हो कि इसका रेंज इतना है सो it should be overflow or it should be underflow or things like that. I hope the concept of underflow and overflow is also clear. Because I don't just want you to be programmers, I want you to be good programmers कि जिनको पता है कि मेमोरी इतनी लेगा और इतनी ही मैं allocate करूँगा. That's it. Again we have unsigned integers. That's why this is really important. Unsigned integers पढ़ना, twos complement, ones complement, वो सारी चीज़ें पढ़ना because this is how computer memory works. So you must know all of these in order to see this. So we have unsigned integers as well. There is something problem as underflow as well. So if you see this, I have given an example as well here. So by default, NumPy either creates 32-bit integer arrays or 64-bit signed integers. Okay, that is by default what NumPy does, and it is also platform dependent. So you have to check with your own platform. Am I clear with this? Okay. That's the first thing. Like we took some list and things like that, and we can control the data types. But while control data types, have that in mind. There is a possibility of overflow and there is a possibility of underflow. You must have control over that. Okay. Then the second way is intrinsic NumPy array creation. So there are, as I told you, there are some functions in NumPy by the help of which we can create NumPy arrays. We can create 1D arrays, we can create 2D arrays, we can create ND arrays. Let's start with how to create 1D NumPy arrays by using functions. The first function we have is arange. Okay, arange is just like range, but here we have just named as arange. What range does is we'll write range of 10. It will just give you 0 to 9. Here I just say np arange. It will output array of 0, 1, 2, 3, 4, 5, 6, 7, 9. Again, I can have the start, I can have the end, I can have the step size, and I can have the d type as well with the arange. Okay, so here I can also have this. This is the step size. I just want numbers from 2 to 3, and I want the step size to be 0.1. These are 3 examples. The first example is the simple range 10. It will create numbers from 0 to 9. Then we have start. Then we have end. So it will create numbers from 2 to 10, but it will be floating point numbers. We have 2.0, 3.0, 4.0, and things like that. Then we have arange with the step size. First it will be 2 to 3 numbers should be created, but with the step size of 0.1. So first it will be 2.0, then it will be 2.1, then plus 2, 2.2, then we have 2.3 till 2.9. Because last element is exclusive. We don't print last element. We don't have this in the range as well. So this arange and range is equivalent. So you can create 1D arrays by using the range function. Is that clear? Is this arange clear? Okay. Then we have something called a linspace. Okay. So what linspace does is, it is more or less similar like range, but the thing is there we keep spaces. So here this is start and this is end, and this is the number of numbers I want. Number of numbers. So I want numbers from 1 to 4, but they should be in total. I want 6 numbers, so they will be obviously equidistant. So let's suppose I like this. If I write 1 to 10 and I want 10 numbers, everything will get printed. For example, numbers will be 1, 2, 3, 4, 5, 6, 7, 8, 9 because I have 10 numbers. But what if I want 6 numbers from 1 to 4? So what will it do is, it will create 6 numbers which are equidistant. So it will create 1, then 1.6, then 2.2, 2.8, 3.4, and 4. So here you can clearly see, and the last element is also included. This is not exclusive. This is inclusive. So हमारे पास 1, 2, 3, 4, 5, 6 numbers है. This is the 6. 1 means the first number, 4 means the last number, 6 means how many numbers do you want in that range, including the first and the last number. Okay? So you can use this linspace as well. This is a function by which you can create 1D arrays. Okay. So mainly we saw two methods by which we can create 1D array. The first method was we can use a range. It is similar like a range function. Then we saw we can also use linspace, a function which by which we can tell I want numbers from this to this, but they should be equidistant, spaced equally, and I want these many numbers. Here I have selected I want numbers from 1 to 4. In total I want 6 numbers like that. Is the linspace clear? Okay. So I don't want you to memorize these names, not at all. I just want you to know that there are some functions. So अगर तुम्हें पता है कि I want to create an numpy array which has for example 6 numbers and numbers should be in the range of 1 to 5 and they're equidistant. You should know there is some function. Then you'll Google it. I don't want to memorize these functions. I just want you to know that there are functions like that. Then we have to see how to create 2D arrays. Okay. I think we're overshooting the time. I think should we cover this? I think this is right time to stop here because I also need some water to drink. So we'll the first thing is we in the creation of the arrays we saw how to create the arrays by using the Python sequences, and the second thing we saw how to create the arrays by using the intrinsic numpy function. In that we saw how to create 1D arrays. Okay, I think in the next session I'll try to wrap up NumPy. So I think it will again need just one more session. So in the next session I'll be also starting pandas. Okay, so now the Python is done. Now we are going to Python libraries which are used for ML and deep learning. So in there we started NumPy, and inshallah tomorrow we'll be covering whole of the NumPy. Then we'll start pandas, and then we'll start matplotlib. Okay, then maybe we'll start Seaborn as well, a little bit of Seaborn. So again, just telling you the map. What are we going to do? Python plus related libraries. And I told you per se I'm not teaching you Python. I am teaching you how to learn. Okay. And that's why I'm again telling you just learn the concepts, not memorize anything. If you know something is there, there are a lot of books. There is Google. Now there is models like GPT. There is Bard and everything. You can just search it up and you can look. But if you know, so this will go. This will first we have done with this Python. Now we are in this phase learning libraries. Then we'll also learn a bit of databases. For example, we'll majorly focus on SQL, learning SQL there. So that's our next step, and then from there we'll also try probability and stats with the matrix, and then we can move on to machine learning and deep learning. Okay, and more you will practice here, and this is some like there are dependencies. जितना तुम इसमें मेहनत करोगे, and these things will look easy because you are people of CS. I'm not teaching the folks who are जिन लोगों ने CS नहीं पढ़ा. You have at least spent 4 years in CS, and I don't even if you do not know anything but out of this course, maybe if you spend 4 months with me, तो तुम you should justify कि नहीं 4 months में मैंने कुछ सीखा है. I have learned something new, and I believe that I can use and hone these skills somewhere. So that's why I go in this fashion, go in detail, because you are otherwise I could have just skipped many other things, but I don't want to skip. I want to, for example, this underflow, overflow, this one is not necessary. So I hope कि तुम्हें you are learning something new, and you will practice really hard. As much as efforts I am putting and our team is putting, you will put maybe 3x or 4x than this, because this is for your benefit. And maybe I have explicitly announced this is the first batch, and the people who are not serious, like I am taking oath, I won't take these people again. क्योंकि मैं next batch हम लोग start करेंगे, the amount of effort that goes in creating these IPython notebooks and these Jupyter notebooks, then amount of effort it takes to explain you the things, it's tremendous. So if you are not willing to take 4x for this, then this is pure wastage, and you have no one to blame but yourself. Okay, I am just waiting for 30 more seconds to take some questions. So if you don't have questions, maybe we leave then. It was a really good session, really good interaction with you. Yes, yes. Mm-hmm. Yes. Oh, this is like not even a silly question. This is not a question at all. The thing is, good that you asked it. Like this basically shows the lack of programming, क्योंकि तुमने बहुत थोड़ा सा program किया होगा. That's why. Like basically functions में हम मैंने क्या बोला? What is function? So function basically is nothing, just a bunch of statements put together. So you can put loops in that. You can put anything in that. So break means like you are getting out of the loop. Return means you are whatever the value you compute out of the function, you want to return that to the caller. So we have calling of function, and you want to return something to the caller. So if you want to return something, that's for the call. And loops are basically used to compute something. That's why like I hope कि तुम्हें assignment में you these things will be clear. So that's why I want you to really work hard. क्योंकि in order to compete with the world, you have to at least, because मुझे लगता है you at least need 2 years, 2 years of full hard work. Initially I thought कि तुम्हारे पास bachelor's degree है and probably you will be knowing the stuff. But it is not you to blame fully, and ऐसा भी नहीं कि तुमको blame भी नहीं कर सकते. There is a blame to put on you and there is a blame to put on circumstances as well. तो 2 साल तो मैं मुझे लगता है लगेंगे कि in order to understand full, and there are people who understand all this stuff, but you people, you should really work hard on these assignments, and if you have question, discuss them. Discussion is okay. If you discuss with the people, that's okay with me. But do not try to copy and the things, because 4 year तुमने ऐसे waste किए. And I don't want you to waste the next coming 4 months or 5 months or so. So I want you to really dedicate your time and things like that. और उसके बाद just think about this कि 4 साल computer science पढ़ा, let's give these 6 months to sort of undo whatever we did in our bachelors. तो हम लोग इन 4 महीने में एटलीस्ट मेहनत करेंगे. देन एक बार मेहनत कर ली, देन तो लाइफ उसके बाद मेहनत कराएगी खुद, बिकॉज यू विल बी एट दैट प्लेसेस वहाँ जहाँ तुम्हें मेहनत करनी पड़ेगी खुद. एंड इंशाल्लाह लाइक बाय सीइंग द मुस्लिम कम्युनिटी हम लोग उनको अपलिफ्ट कर सकते हैं, बिकॉज पीपल लाइक यू, व्हेन यू विल लर्न कोडिंग ऑन योर ओन, देन यू विल हैव सम कजन्स, सम ब्रदर्स लाइक हियर एंड देयर, तो तुम आराम से उनको गाइड कर सकते हो. So good that you are like telling me the real questions, that whatever you are facing right now, even you can message me sometimes, you can message in the group. Think this group as like you don't need to sort of embarrass anyone, or तुम ऐसा नहीं लगना चाहिए कि this is so silly question, I should have not asked it. So it's okay, because right now you are in that learning phase. Even I make mistakes, I am a human, I make mistakes, okay. So mistakes करना अच्छी चीज़ है, but not to commit mistake, it's a problem, because you might have read that quote, mistakes are the proof that I am trying. When you commit mistakes, at least it is a proof that you are trying something. But if you are not even committing mistakes, then it's saying कि ये बंदा कुछ भी नहीं कर रहा, and then not he is not committing mistakes. तो मैंने बार बार हर चीज़ में बोला है, first thing is acceptance, accept the level that you are at, and then let's move towards the progress. और उसके बाद ये चीज़ें हम लोग करेंगे. Whatever you have done in your past, forget that. Let's start new, fresh, and I hope कि इन session से तुम्हें फ़ायदा मिल रहा है. So that's my only hope. Okay, then if you have no questions, maybe we'll close the session. It was nice once again meeting you people. Thank you so much for being so attentive. Assalamu alaikum.